Welcome everyone. Today in our Secure Solutions YouTube channel, we are going to learn how to do penetration testing on perimeter devices. So we have lots of perimeter and infrastructure devices available when we go with penetration testing for your clients in a particular organization. That time we will do penetration testing on devices like router, switches, IDS, IPS and firewalls, right? But people are not aware of how to do penetration testing. People don't have idea, in fact, how to start with penetration testing of these perimeter devices. So that's the main motto of this video. So we'll start with penetration testing of perimeter devices. Definitely at the end of this video, definitely you'll have an idea, okay, this is what penetration testing, how you will start penetration testing with the devices. So majorly today I'm going to cover only two devices in here. I'll cover the router and the switches. I'm not talking about IDS, IPS or firewalls in this video. Why? IDS, IPS and firewalls, you'll find lots of stuffs. You will find lots of bypassing techniques using Nmap, and lots of security auditing tools are available that you can go on in the market, that you can make use of it and you can utilize those tools to do on. But when it comes to routers and switches, we can't find much when it comes to the penetration testing of routers and switches. So that's the main motto of this video, and now we'll get into the main stuff that we can go on. Okay, so we'll cover router and switches. And in router, what's the need actually? The main need of the router security auditing is once your router get compromised and your whole network is compromised, right? So that's why we need to secure our routers. That's why we need to do penetration testing and security auditing in our routers. Okay, and we are going to use simple tools like dig and NSLOOKUP. For why we need to do these things? Because sometimes organizations and clients, they have put their router as a DNS server. So that's why we use these tools to enumerate more information regarding that, the DNS stuffs, and then we have to scan the ports which is open in our router. And we have port scan. You can go on with Nmap that you can do. Especially you need to check the port number 10999. Why? This port reveals a lot of sensitive information about your network and about the device that you are using in your network. Okay, that's why we need to check for data leakage in your network using this port. And if you are using this port, and you need to close it immediately, and you need to run an operating system scan in your router, and you need to find the discovery of protocols and test for TFTP. Why we need to scan TFTP? We all know TFTP, trivial file transfer protocol. We use this to push up firmware upgrades and the router configuration files in our network devices. So that's why we test for TFTP services, and then we try to retrieve configuration files. So when you get into the files, you can easily find out the passwords and lots of sensitive information in the network. Okay, so in here we have the next one, check for router misconfiguration and test for VDI and TTY connections. So obviously we know virtual terminal, once you have the physical access to the console port, then only you can get into the VDI and TTY connections. So if you are an internal network penetration testing, then you should perform this. Okay, and then next we have remote access. Try getting remote access to the router's console or switch console. How? Try connecting the router using SSH or Telnet, and you can get login prompt. If it is not secure, you'll get a shell access directly. Okay, so you can try that one. If you have any login prompt, then you need to brute force it. Okay, and you have testing router configuration. What are the things that we need to check in router configuration? The exploitation of routers, when we have CVEs, when you have the vulnerability which is already being present in there you can exploit those vulnerabilities, and you can exploit the vulnerable services and the outdated firmware and patches, right? Those things you can go on with full exploitation, right? We do with the normal endpoints. But basically what we do with penetration testing on routers and switches, we stick with security baseline. So we compare with that baseline and we check each and every device is configured properly or not. So we check for router misconfigurations, and we check for running modes and what are the misconfigurations and loopholes an organization is leaving, that an attacker might use it for malicious activity, right? So we use mode, user mode, we have privilege mode, and we'll get into that mode, and enable mode is also known as privilege mode, and we get into that mode and we'll check that there is authentication is there or not for configuration mode and this modes. Okay, if you have, whenever you get into that enable mode into the router, when you get the hash symbol, that means the system is not configured, the router is not configured with the authentication, then you are directly into the console. So if it has any passwords, then try to brute force the password. Okay, and the next thing we have in here is SNMP capabilities. Why? Most of the routers are being managed by SNMP. So we have several clients also like HP OpenView and IBM Tivoli to manage routers. And we all know SNMP version 1 is vulnerable, and we can use SNMP sniff to sniff out the passwords in plain text. And you can use SNMP brute forcing technique to decrypt the community strings, and you can track the default community string public in most of the routers where they are using SNMP version 1. Okay, and we have SNMP capabilities, and then we have finger services. What is this finger service? If your router is enabled with finger service to manage your router, and this finger service majorly runs with Unix and Linux operating systems. So when we try this finger services, and you can do enumerate lots of stuff using this finger service. So when we try finger and at the rate of IP address of your router, it will give the list of logged in users into the router, and then with that user, and you can enumerate lots of information that what that user possesses according to his authorization. Okay, so these are the information that you can get in here. And you have CDP. So next, now we are slowly moving towards our protocols that we need to look for. Okay, so what we do, we look for several protocols, that these protocols are properly configured, or is there any misconfiguration that happened when the client is trying to implement it. So we'll start with CDP. So test for CDP. What is this? CDP, Cisco Discovery Protocol. It's a layer 2 protocol that discover each other Cisco devices in the same link. Okay, to manage Cisco network across the organization. So CDP, this protocol particularly sends the messages like device ID, that is host name, then port ID, the port information about the sender, then operating system, iOS version being used, and capabilities of routers, and network IP address. So this much of sensitive information are being sent by this CDP protocol. So it is advised to disable the CDP protocol in an organization if it is not necessary. Okay, so we can use CDP sniffer to sniff out the passwords and to sniff out the sensitive information. And to disable the CDP, if it is not in use, and if it is not necessary or mandatory for your organization, then you can disable it globally, and you can disable it in an interface using these commands. So we will be learning how to disable this with the help of Cisco Packet Tracer. I'll be doing that lively. Okay, and next we have in here is test for NTP protocol. So what is the NTP protocol? NTP protocol, we all know network time protocol that we use to gather information using network time protocol. We have one more video. I'll leave that link in our description below, and you can go on with that video also. And in here, for NTP protocol, what's the use? It will be used on border routers enabled by default to synchronize the internal servers with the border protocols, with the broader servers, and with a single cluster and with another cluster. So if a cluster holds lots of devices with a border router, and we need to configure this router with NTP to synchronize with the next cluster. Okay, so a potential attacker can corrupt time if it is enabled. So you can go on with NTP date in your IP of your router to synchronize and to check out more information on your routers, and you can verify. And this practical session I've already gone through with lots of commands in our previous video named as enumeration. You can go on with that, you can check it out. And you have strict and loose source routing. What is this? We'll come back to these commands once we find what is strict and loose source routing. For example, we have multiple routers, R1, R2, R3, R4, R5, and then we have a client. If R1 is sending a data from R1 to client, and it should take a path like R1, R2, R5, or it may take R3, R4, R5. right? And for example, network administrator or whoever concerned person can mention this routing in what way it should reach the client. If I mention R1, R2, R5 client, that is stick source routing. If I mention R1, R4 and then client, that is loose source routing. That is mentioning of each routers in the path is stick source routing, and mentioning of very few devices and a few routers in the path, that is loose source routing. Okay, so we need to check this one, and you can perform this command using your command prompt, and -J for loose source routing and -K for strict source routing. So you need to mention your host, and it will clearly mention, okay, this device is going on with strict source routing and loose source routing. So now it is very easy with strict source routing and loose source routing. And then we have IP spoofing. That's for IP spoofing. What is this? You need to check for external and internal IP ranges, and check for access control list on the router, and test for ARP attacks, and test for router information protocol. We all know that. So ARP attacks we can do with EtherCap, and that's very easy, and we all know that. And we can check for access control list. Once we get the router console port, we can try that, enumerate that, and check for internal and external IP ranges too. Okay, so we'll start with RIP, and before that we'll finish it up HTTP vulnerabilities. What is this HTTP vulnerabilities? We have the plug and play feature which is available in routers to transport your iOS images and all the configuration details of your router, right? If it is enabled in your device, anyone can steal your data and information using this curl command. So curl HTTP and your IP, and that runs in port 8082 and SMB, and you can mount that temporary data into a text file from that USB device. So if someone is plugged in already the plug and play devices, for example like USB drive, USB stick, and an attacker can easily get out all this information using this simple command. So and then you have to check for self-sign certificates also when you go on with HTTP vulnerabilities. Okay, and next we have RIP. So here we comes to the part where we need to check the protocols, various protocols. So we have routing information protocol to advertise the network, to introduce to the other network. So if you have a device, one router and another router, you need to introduce two routers to each other, okay, to communicate with each other. So for that we use these commands, router RIP, version 2, network IP. You'll not get anything what is this commands at all if you are not very majorly into the network security, and if you have already done CCNA course, I'm damn sure that you are well aware of this thing. Okay, so you can go on, you can brush it up once again if you can't remember these commands, and then you can get into the network security of routers and switches. Okay, so next we will see what protocol. The next we have one, we have OSPF protocol, open shortest path protocol. What is this one? Why we need this? We have multiple routers in our network or in various network, right? So we need to mention which router or which path it should take efficiently to reach the client. Okay, so that's where we use OSPF, and OSPF runs with various tables like neighbor table, topology table, and routing table that stores OSPF neighbors and topology structure of the network, and stores that best routes respectively. Okay, and it uses authentication, and it uses two types of authentication. One is plain text one, and another one is MD5, where your router will automatically change to MD5, automatically change to plain text password when your neighbor router doesn't support MD5. Okay, and if it supports MD5, and it will automatically go on with MD5 if you have enabled it. Okay, so we will see how to enable the authentication, how to configure OSPF, everything. I've covered all the stuffs in here, but you have to be very careful. I haven't started the basic stuff that you need to learn from CCNA. Okay, so I've just covered how to do this configuration of OSPF, how to do the configuration of the various protocols. I think this will give you an idea then where you can start and where you can, how you can proceed. Okay, so that's what's the main motive and main objective of this video. Okay, and next protocol we have in here is EIGRP. What is this? It holds the characteristics of distance, vector, and link state routing protocols. Okay, so EIGRP is mostly for Cisco routers, and it helps in large and complex network, and it is preferred over RIP and OSPF protocols. Instead of using two protocols, you can go on with one. So EIGRP will do the both of the work of that RIP and OSPF does, and it holds the table information like neighbors, topology, and routing. So same thing we can do in here with EIGRP also. We will see this configuration also in here. And next we have BGP protocol. And what is BGP? Border Gateway Protocol, that is used to communicate with two different autonomous systems, two autonomous network, where attacker tries to hijack this BGP sessions so that they can malform the routing table information. So once they are malformed and whatever, they are in the network and they can do whatever they want. So how they will do this? By predicting the sequence number of TCP. So whenever you're sending a TCP session or TCP communication, the session is established, and you can check out your TCP sequence number when you sniff out the traffic using your Wireshark. Okay, and you have to predict your sequence number. For example, user A, B is there and they are communicating with each other, and C is a attacker. And what attacker will try? Attacker will sniff out the traffic and he'll try to guess the sequence number. And once the user A sends the data and he can guess the sequence number, it is going on with 10, for example, and in return user B returns with 15, and then user A sends again with 25, and then user B returns with 30, and then user A sends the data with 40. That means you can easily guess out user A sending the sequence number in the range of 10. And then for the next time, what you can do with the same sequence number, you can take out the session and you can hijack the session by duplicating the sequence number, and then you can hijack the BGP sessions. So that's how we do with BGPs, and we can predict the session numbers and we can take down the BGP one. Okay, and that's how attackers do take out the BGP sessions. Next we have DOS attacks on routers, and you can carry out the sync flooding attacks that we all know with HPing, and we have HOIZ. We have multiple tools are available to carry out the sync flooding attacks, to carry out this one. And we have tools to check out the security auditing stuffs. So we have secure Cisco auditor that can be used for auditing Cisco firewalls, routers, and switches. Okay, you can check that out, and it's a paid one. We need to pay, obviously. Okay, and we have switches now. So what are the things that we can check with security of switches? Stick with the security configuration baseline. Misconfigurations are default vulnerable configurations, unused ports, and we need to check out the DHCP snooping is enabled or not, and port security is implemented or not, then correct timestamp. Okay, we'll get to know about what is DHCP snooping in here. And in DHCP snooping, we enable this DHCP snooping to avoid rogue host and rogue strange hosts to get connected with this trusted DHCP servers. To avoid that thing, we need to enable this DHCP snooping. So these are all the steps that we need to carry out to enable and disable the DHCP snooping globally on VLANs, and to make trust the interfaces, and to add DHCP snooping to the option 82 and to the relay agent, and to get to successfully add a server address on an interface. Okay, so these are all the steps that we need to carry out our DHCP snooping. Okay, and we have port security, where we can limit out the MAC addresses that allowed to the switch ports. Okay, to restrict an interface by limiting and identifying MAC addresses of the workstation that are allowed to access the port. So configuration of port security, we will see that, and then we have all these various stuffs that we need to test for. We need to test for address of cache size, then test for data integrity and error checking, and back-to-back frame capacities, and frame loss, and test for latency, test for throughout, and all this stuff. So all these stuffs totally based on frames. So once you know how to calculate your frame, and you can easily go on with all the testing types. Then we have VLAN hopping attack, and then we have spanning tree protocol attacks. So we will see these two attacks also, and how you can carry out these protocols attacks with a tool called Esenia in Kali Linux. Okay, and we have MAC flooding attack. We all know we can carry out this MAC flooding attack with MAC-OF tool, and ARP attacks that you can do with Ethergap or Petrogap or any man-in-the-middle attacks. You can do it with Canonable, right? And then you can check for VLAN trunking protocol attacks. Then you can use Switch Center and Traffic IQ for security auditing and monitoring of and performance using switch center and traffic IQ. So switch center will help you to carry out these monitoring stuffs to test for frame loss, latency and throughout, and frame error filtering. So in this video we will not cover this thing, test for latency, throughout, error, all these things. We'll cover all the protocols, and then we'll go on with how you can start attacking VLAN hopping attack, and you can carry out your spanning tree protocol attacks, how you can do that. Okay, we will try it out with Yersinia. So now let's get into the practical session in here. So now we try to disable CDP. And I can enable or I can disable the CDP globally from in here. No CDP run. I can go in this way and that will work. I've just disabled now, and if you want you can enable it in this way, CDP run. It will enable it globally, and I don't want this now, so I'm disabling no CDP run in this way. And then if I want to disable it in any interface, I'll just go to the interface and I will enter the serial or any port that I want to disable. And what's the serial port I'm using in here? Let me check it. 0/1/0. Now I can get into the interface. Now I will do no CDP enable. So in here I will disable the CDP. So in here I'll disable the CDP in this way. Okay, and the same way you can work on with NTP also. So let me save this and then we'll try with NTP. So how we do the NTP enabling and disabling? So once we are in the enable mode, next we need to move into terminal mode, configure terminal, then you can go on with feature NTP. So if your NTP doesn't work in this way, you can go on with NTP, then press question mark, and you can see there is a master, server and trusted key and authentication key, all these things. What is this? If you want to create your router, you want to add your router as your NTP master class, then you need to create the master first, then you need to configure your NTP server using server, then you need to maintain your authentication. Okay, so that's what we need to do. And if we don't have anything, we'll just go on in this way, NTP master. So you have set it up your router into your NTP server, then you can set your NTP authentication key. So NTP authentication, authentication key. Then I need the key numbers that you can give. If you don't know anything, just go for help. It will clearly mention what you need to do, and then just press once again, and I need to go for MD5 authentication. Then I can give the password. Password can be anything like this. Okay, so you can give anything like this, then press enter. It will set up the NTP password, right? And you can add your access list also using trusted key or update calendar or anything you can play on after this, right? That's very easy to configure NTP and CDP. You can disable NTP and you can disable CDP very easily. So no NTP master, you can go on in this way, it will disable the whole stuff. Okay, so and you can disable your NTP authentication also with a no command in front of all the commands. Okay, this is how we do play with NTP, and we have already explained all the stuff, theoretical ones in the early stages, early theoretical session, but it's a very basic one that you can do. How people authentication and all these things, we will check it when we go on with pen testing, and we have a lot of stuff to check more than this, so you can spend a lot of time on that. Now you have an idea how you approach a penetration testing on infrastructure devices like routers and switches. Okay, so that's it. So let's do our router information protocol configuration in here. What we can do with RIP. RIP's major concern is used to communicate with the next router, to communicate with each other. So we need to introduce all the networks all the interfaces or all the networks to communicate with each other. So how we do that? We need to be in enable mode, and I need to be in configure terminal mode. Then I can go on for router RIP, right? And you can go on with version also, any version. So I just need a version 2 in here. Okay, just go for help, and you have going to introduce your network. Okay, so how you can introduce your network? You are in router 0, and router 0 holds the IP address 10.0.0.1. okay, so if I need to introduce with other network, we have 30 and we have 35, two more networks are there. So how I can introduce it? So I need to introduce network 30.0.0.0 and 255.0.0.0. okay, I think I don't need subnet here. Okay, then I can introduce network again, and that should be 35.0.0.0. okay, in this way you can introduce your network. Okay, why? Once you introduce, you can communicate freely inside your network. You can contact, you can ping your another device also. That is very possible in here with this route information protocol. Otherwise you cannot communicate with the other network. So that's why we do RIP protocol in here. This is very easy, very basic one that we do, the router information protocol. And we have OSPF next, and we have EIGRP and other protocols. Okay, so in here in the RIP we have introduced the network, and now you can go back and you can check what is your route that your router is taking. Okay, so how you can do this? Just save it and you can show IP route. Okay, so this will clearly say what route it should take and all, and I've already mentioned it, and that's why it's not showing. And it is that I've already did this, and that's why it's showing all the networks in here, and no need to worry about that. And every device in my network is now connected. Every router in my network is connected properly with this RIP, so I can ping any device with ease. Okay, so that's how you do RIP protocol. RIP protocol is very busy, very basic, that how you introduce another network into your network, and it's very mandatory to for communication. Okay, so that's how you do this. You can do the same thing with your another router also by introducing the previous network, that is router 0 network, into the network, and then you can do it. Okay, so that's what we have in RIP, and then we move on to the next protocol. So in here we'll see how to do the OSPF configuration with our router. Right, in this session we'll see that one, and we have things to check in OSPF configuration, authentication, everything. So we'll do one by one. We'll start with, we need to be in enable mode, and then we have to be in configuration T mode. Then I need to introduce the network, right, the adjacent networks. So I'm going to introduce the other network, that is 30.0.0.1. so I need to introduce that one, 30.0.0.1 and 0, sorry, and then subject mask I can give 255.0.0. then I need to give the area number 2, so area should be 1 or something like this. Okay, and I think I've made some mistakes. Yeah, of course I have to be in the protocol first. I need to enable that one, right? So router OSPF, right, and then I need to give the process ID, so I'm just giving process ID 1. Now I'm in router mode. Then I need to do network and T.0.0.0 and 55.0.0.0, then area 1. Now it worked, right? So this is how we do introduce our next router. It should take the open status patch protocol. Okay, that's very easy in here, and in the same way we'll do this in router 2 also. And if you have another network, you'll introduce that also. Okay, so I can give like a network 35.0.0.0, 55.0.0.0, and area 2. So if I give like this, it isn't going into the next area. This is area number 2. Okay, so I've just given this thing in area router 1, and I can give the same thing to router 2. Okay, in the sense, my bad, router 0 and router 1. In OSPF protocol, we'll do configure OSPF protocol with the network, the adjacent networks, and OSPF runs with various authentications. So we'll get into configure terminal, and then router OSPF, and I need to give the process ID also. I'm giving process ID 2 in here, and then I'm now in router mode, router configuration mode. Then I'll do now network, the introduction of network with the adjacent router. So network, I'm just giving in here the next router IP address, that is the series of 30.0.0.0, then subnet mask 225.0.0.0, and I need to give the area number, that should be 2, and I can introduce another network also in here if I have one more network. Okay, but for now I'm not going to do that. I'm going to authenticate. I'm going to check for OSPF authentication. So how I can do this OSPF authentication? We have two types of authentication. One is plain text and MD5, and for that I need to be in interface mode. So I'll just save this now and then I'll move on to that interface mode. So now I'll go on with interface and configure terminal mode, sorry for that, and then I'll go into the interface mode and then serial 0/1. Okay, so this one I just in the router config mode, then now I'll do IP OSPF, and you can check for help in here, and it holds all the information that you need to do. For enabling OSPF, you need to go on first with authentication. For enabling OSPF authentication command. Okay, and you have network, you have priority, authentication key, messages key, all things in a single place. Okay, so for that now we are going to use authentication in here. But for enabling authentication, if you have just given authentication alone, that will enable your password, your authentication technique, authentication mode into a plain text one. So I need to give in here as message digest, and then now it enables the MD message digest function for authentication. Now I need to give the message digest key, the authentication key actually. So instead of going authentication key, it will enable the plain text password. So for now I'm going in here with message digest key. So message digest key number, I need to give any key numbers. So I'm just giving in here 3 because I've already mentioned 2 and I've used already, and then I'm giving here MD5 and I can give any password just like that. Okay, and now I just enabled the OSPF authentication here and successfully. Now let's get back to our normal enable mode and then we'll check our OSPF is enabled in here or not. So I will just save this by pressing Ctrl C. Then now I'll show IP OSPF neighbors, or you can check multiple routing topologies and also. I will just get with interface serial 010. Let me check. Now you can see message digest authentication is enabled, and if you're enabled without any message digest function in there, and it will enable your plain text password. So that's why we use message digest function when you are enabling your authentication with OSPF protocol. Okay, and this is very basic one, and this is how you need to check your client router has been enabled with OSPF protocol with authentication of MD5 or not. I'm in router 1 now. We'll do the EIGRP configuration. Okay, so what's the advantages of EIGRP? We have advantage over RIP and OSPF. EIGRP do both the work that RIP and OSPF does. Okay, so we have to be in enable mode and we have to be in configured terminal mode. Okay, then we can go on with enabling router EIGRP. Okay, then we have to give ASN number, autonomous system number. So I can give any number. So if I don't have any autonomous system, so I'm just giving 1 in here, and I need to introduce the network. So I'm in network 1 actually, so I need to give network, and I need to introduce the network in here, and I'm going to introduce the network 30.0.0.0. then I need to give the subnet mask too, so 255.0.0.0. so I'm just giving in this way, right? And I need to introduce another network too. Network, I can introduce another network, so 10.0.0.0. I can have the subnet 25.0.0.0. okay, so if I give in this way, it's very easy to configure EIGRP. Okay, and if you just go on in this way and you can open router EIGRP and you can just go for help, you can easily find out what you can do. You can specify a neighbor router. Okay, so if I specify neighbor router NEIG, okay, NEI neighbor, I can specify the neighbor router as 30.0.0.1. okay, so in this way I can specify my neighbor router, right? That's very easy. And neighbor address I need to give in here. I've just given in the same way, and it's okay. And I need to give the serial, so serial, and I need to give the serial interface number. What serial interface number I'm using? 010, right? So in this way, right? So now I just configured my neighbor and router is 30.0.0.1. So in this way you can easily identify, you can easily configure your neighbor router, everything. Why? We have seen that EIGRP takes over the advantages of RIP and OSPF that holds three tables: neighbor table, topology table, and routing table information. So it holds all the information of neighbor, routing, and topology, right? So we have all this information gets stored in with EIGRP. So that's how we do EIGRP. So let's check out it is saved in here or not with this one. So how we do check it? It's very easy. So show IP route. Okay, so that's very simple, that's very easy. This is how we do check it out, how this is configured or not. Okay, and I can go on like this. So show IP EIGRP and go for help, and it will check, it will go for interfaces, neighbors, topology, and traffic tables too. So if I give neighbors, enter, and for process 1 I didn't get anything, so I can go for interfaces now. Let's check. See, can you see this? We got this configured with serial 1 and gigabyte 1. So this way you can easily check it out, the EIGRP and everything. Okay, so I haven't configured, I haven't introduced with the router 1. So if I did, and it will give me the proper result I will be having in my hands. Okay, I've just done it only with the router 1. I haven't done with the router 0. That's why I'm not getting any proper results. So the same method will follow with router 0 also. And we need to bring up all the interfaces to up. There's one interface is down, so we need to do that. Okay, and we have BGP protocol. So what is this BGP protocol? How we do BGP protocol configuration? That's very easy. You have to be in configuration mode. So get into configuration mode, then you have to get into the protocol, that is your BGP protocol. Next, go for help, and you need to introduce your autonomous number, and I'm giving autonomous number 1. And then you can introduce your network or anything, neighbor or any information. Okay, let's go for help. You can see network, specify a network to announce via BGP, and you can specify any neighbor, or you can go for BGP specific commands or anything. So if I go for BGP and go for help, see, you have lots of help, distance, neighbor, lots of stuff in here, right? So that's how we do. So BGP, and you can check it out. Timers, synchronizations, and log neighbor changes, router ID, lots of information you can do with BGP. So BGP works like border gateway protocol, which sits in the extreme ends of a area or autonomous system or different clusters of network, and where you synchronize, and that's where you play with BGP protocols at border gateway. Okay, where it needs to synchronize or where it needs to communicate with the next border gateway border gateway. Okay, where you need to synchronize different various protocol, where for example you have different cluster that is running with EIGRP, and you have BGP1 in here to synchronize. So that way, right? And you have BGP in here, and let's check. And neighbor, I need to introduce a neighbor. Okay, let's introduce a neighbor, and neighbor I'm introducing 30.0.0.0 network, and that is always my network, no issues. I'll introduce, okay, 30.0.0.0, and I need to give remote ASN number, and that number should be anything 1. Okay, so only external neighbors, sorry, I have to give the external neighbors. Okay, yeah, now it is done. That's like I have to give the specific ASN number, because we have to introduce two various different sets of protocols. So if there is OSPF or EIGRP running, and I can synchronize or I can connect with BGP. Okay, so this is how we do, and we can check it out what is a neighbor or neighbor IP address also. So how we do this? Show IP BGP all neighbors, or you can so neighbors in here itself, neighbors. Okay, so you can check it in this way, and it will clearly give you who's your neighbor. Now BGP neighbor is 30.0.0.1, this one, and I think I have enabled that one. Yeah, I think I've enabled that one also, I think so. And router ID, yeah, we got lots of information in here, and This is how we do introduce various networks and various protocols using BGP. For example, just actually I'm not going on with so you can see this BGP neighbor is 10.0.0. We introduced remote as 2, right? This is 2, that is 1, and we got the result in here. So for example, this is a very basic one, how you configure BGP. But for configuration of BGP for complex network, various networks, you need to understand deeply in what way you have to work on routers. So it takes more time and it takes more deeper knowledge on CCNA. So spend some time on this networking and definitely you'll get into it. Okay, so that's how we do configure BGP also. Next we have how to do configuration on switches. We'll get into it. Okay, so here we are going to do a security measure that we need to take in switches. DHCP snooping. We all know why we do DHCP snooping. We have seen that in our yearly theoretical class, and we'll do the practical session how to do the DHCP snooping in here. We have various steps to do that DHCP snooping, and we'll start with enabling DHCP snooping on VLANs and various interfaces, and how to trust your devices interfaces, and how to configure DHCP snooping and relay agents, and how to enable option 82. So all these things one by one we'll see in here. Okay, so for that I need to enable to be in enable mode, and I need to be in the configure terminal mode, right? And then what I can do IP DHCP and go for help, because we're going to execute snooping. So I'll just enable snooping, and if I click enter, it'll enable IP DHCP snooping. Okay, if you don't want to enable the IP DHCP snooping, you need to disable it, and you can go on with no command, no IP DHCP snooping, and that will disable your DHCP snooping. So I don't want to disable it now. What I'm going to do, I'm going to verify it first with MAC addresses, and we have lots of methods to do our OH DHCP snooping in the checklist what we need to do. Okay, so before what I'll do, I'll just enable now, and I need to enable IP DHCP snooping in VLANs. Okay, and if you have any particular VLAN list, then you can add that VLAN number in here. I don't have anything, so I'm just giving in here 1. Okay, so I'm just giving in here 1, and with that one, now what I'll do, I've enabled DHCP snooping and VLANs. Next I'll do enable verification of MAC addresses. That's what we do in DHCP snooping, right? So what we'll do, IP DHCP snooping and then question mark. So this is what we're going to do, verify, and hit question mark again, it will give you MAC address, and hit question mark again, you need to enable MAC address first. So I'm just enable IP DHCP snooping verification of MAC address, right? Then I need to enable the option 82 that gives extra authenticity for your DHCP snooping when you're carrying out this DHCP snooping. What is DHCP snooping? We do avoid connection of and the communication of rogue DHCP hosts to the trusted DHCP servers. Okay, so that's what we do in here with DHCP snooping, and we need to enable option 82 for that. So how you can do that? That's very simple. IP DHCP snooping. Okay, IP DHCP snooping and information. Okay, and you have option in here that will enable your IP DHCP snooping. If you don't have anything, just go on in here and you can allow everything, allow untrusted also, and you can go for enabling by default. Okay, so I've just enabled option 82 for now, and then I need to enable the trusted interfaces. How you can enable trusted interfaces? That's very easy. You need to be in interface first for that. So I will go on with interface, and then I'll use one serial port, right? And serial, and the port, not actually serial port, I have fast Ethernet port in here. So fast Ethernet, and fast Ethernet port should be 010, I think so. Let me check it once. Fast Ethernet 02. Okay, so we have that fast Ethernet 02 interface, and now I'm in interface now. And then what I'll do, IP DHCP and snooping, then I'll just go on with trusting. So you have trust configuration and you have limiting configuration. You can go on with anything. So if I just go on with trust configuration, okay, and I just need to hit enter. Okay, so I've just made that interface into a trustable one. Okay, and now I can enable my DHCP relay agent. How you can enable your DHCP relay agent? You need a relay agent for this DHCP snooping configuration. So I need to enable that DHCP snooping one. So I just go back once because I don't want to be in interface mode. I need to be in configure terminal mode only, and I will just enable service DHCP. This will enable your relay agent, and you need to enable option 82 on relay agent. Previously we enabled option 82 generally, and now we are going to enable option 82 in your relay agent. Okay, so how you can do this? So I'm in configure terminal mode, then IP DHCP, and then relay information option. So now you are enabling that thing in your, okay, so 1 second, let me check it what we have. Yeah, we have to trust all. Okay, now we just enabled our DHCP snooping and option 82 in relay agent, right? And you can enable your DHCP snooping on a particular interface. Okay, how you can do that? You just need to get into that interface. We have already seen that thing previously, the same thing. Okay, and you can go on with VLAN also. So I can go on with VLAN or any LANs you can have. If you have any LAN number, I've just given in here number 1, and that will enable DHCP snooping on that particular LAN. On we have that interfaces. These are the things that we have seen in here up to now. What we have seen, we have enabled the trust issues with MAC address and VLANs, common enabling of option 82 and option 82 on relay agent, and enabling of relay agent. These are all the things that you need to do when you go on with DHCP snooping. Okay, so let's check our DHCP snooping is running perfectly or not. Let me save it by pressing Ctrl Z, and now I'll just snoop IP DHCP and then snooping. Check out, yeah, faster than, yes, unlimited. So this rate limit we can just check it, we can alter it when we have seen this thing, right? This one, IPDHCP snooping in an interface. So you can limit out. If it is limited, then that's only allowed, right? So that's how you do configuration of DHCP snooping. Yeah. And we have for switch port security also, the next one. So in switch port security, we all know why we do switch port security, what's the importance of switch port security, and why it is necessary to do this configuration in your switch devices, right? And we do these things in interfaces to make your switch ports into a secure ones, so that you can limit your connections and limit your MAC addresses to a particular interface and particular port. Okay, so that's why we do this switch port security, and for that I need to be in config mode first. Okay, then I need to choose an interface. So in here I'm going to use the same thing, fast Ethernet 0/2, right? And then I'll go into switch port and mode, right? And then I can go on with access. So what is this? It will assign port as host. Okay, this command will assign port as host. Then what you can do, you can go on with other commands like switch port, and then you can go for this question mark, and it will clearly give you this port security. This is what we're going to use in here. So that's very easy, and you can go on with port security, and you can go for again help, and in this you can check for this aging, right? And you can check for multiple commands like MAC addresses, maximum secure addresses, or violation mode. Okay, multiple things we have in here, and we will go on with maximum. I will just going to allow only one devices by limiting the devices number into 1, and then I will shut down my violation. Okay, and then I'll go on with MAC address sticky one. Okay, so in here port security and maximum, right? And then I'll go on by limiting into 1. Then I will go on with the same command, and in here I will go on with violation, and I need to shut down the violation in here. So I just shut down the violation. These are all the checklists that you need to check to do your port security on your switch port securities. Okay, I've shut down the violation, and then I'll go on with my MAC address sticky stuff. Okay, and you can go on with this one, and you can specify your 48-bit MAC address, and you can go on with sticky. Okay, so configure dynamic secure addresses as sticky one. So it will configure the dynamic secure addresses so that your switch port will be more secure. Okay, so that's it. This is how you do your switch port security, and you can check your MAC address table, and you can check your verification of your switch port security in your not in your configuration mode, in your enable mode. So I can just go on by exiting it, and then I'll do verify in here. So that's very easy. So show port security. Okay, so 1 second. Okay, sorry, I'm in configuration mode only. I just need to go back once again, and in here I can do that show, then switch port, so port security, right? So that's very simple, and click enter. And we don't have any port security. We enabled in any interface. Yeah, we enabled in interface, right? So show port security, and I can go on with interface, and that is fast Ethernet and 0/2, right? And you can check port security is disabled, and let me check it why it is showing disabled. I enabled previously, I think so. And let me get into my configuration mode once again, and then I can go on to my interface, that is fast Ethernet 0/2, then switch port security. Okay, so switch port security. Okay, I think I've just enabled everything. Let's try once again. Aging MAC addresses violation, everything is done. Okay. Okay, access mode, enabled it. Let's check now. Yeah, now you can check it out, it's enabled now. So by mistake, I think I've missed a command in the middle maybe. So this is how we do port security in your switches, right? That's very easy, and you can go on and secure your devices in a very proper way by configuring DHCP snooping and switch port security. And we'll go on with next other two attacks that we can carry out, that is your VLAN hopping attacks and spanning tree protocol attacks. We will see that in the next section. So we will do our switch attacks, various switch attacks in here, and we have two attacks in here. First one we'll do with spanning tree protocol, and then we'll do with VLAN hopping. Okay, so in spanning tree protocol and VLAN hopping, multiple layer protocol, second layer protocol, third layer protocol attacks we can perform using a tool, the inbuilt tool called Nmap. Okay, you can launch this tool by default command -G for GUI interface, and in case if you can't launch it, if it is showing it's not available, then you need to install using your Kali repository apt-get install and Nmap. Okay, so this is how you install Nmap, and I've already installed Nmap, so I'm not going to install again. So I'll install now, I'll run now Nmap with this command, and now okay, I got Nmap in here, and you can see we can perform lots of protocol attacks. DHCP starvation attack, you can do trunking attacks, you can HSRP, and can you do spanning tree protocol attacks, and you can do virtual trunking, VLAN trunking protocol attacks too in here. That's very good. And you have to mention source MAC address and destination MAC address. Everything will be done, right? That's very easy to carry out all the type of protocol attacks in here. Now we'll go on with our spanning tree protocol attacks. In spanning tree protocol attacks, to launch, we need to edit our interfaces. So I need to choose an interface that should be my Ethernet 0. It's already selected, and I'm going to attack the attacks using choose launch attack option. And you can see there is a lot of options in here, sending BPDU and sending TCN BPDU. What is this? Like actually data units, okay, protocol data units. We are going to send it in here, and we are going to start with TCN attack. Okay, what is this TCN attack? Sending TCN BPDUs. What is this TCN attack? It will create a DOS attack on your topology change notification using topology change notification. What will happen when we send lots of topology changing notification? Switch will observe this notification, and it will try to change its aging time. So by default, if you have any time between 300 to 400, and it will try to change the seconds into 15 or very lower period of time. Okay, and what will happen in the meantime, if an attacker we give any fake TCN, that means topology change notifications, are sent continuously when there is no topology change in the network. So what will happen, attacker will be sending these things, and switch wants to forward and wants to clear all the MAC addresses in the table. And the record is always not found when a switch wants to forward a data frame. Okay, and so what will happen in the situation, switch will send out broadcast. So switch will send out the information by broadcast, and the broadcast information will be exposed to the entire network. So that's what we're going to do by sending TCN packets, or you can do the DOS attacks also. And if you have checkbox checked in here, that you can carry out DOS attacks in here. I'm not going to do DOS attack. I'm just simply sending the TCN packets in here, and I'll just click OK, and you can see my packets are being sent in here. Okay, so STP protocols, it will send in large flood mode. Okay, for some reason my colleague got hanged. Okay, launch stack. I think I should choose this sending multiple BPDN packets, so that I can, yeah, I'm sending multiple BPDU package, TCN BPDU package. So it will create like DOS attack. It will rush all the packets into all the units into this device. So your switch will broadcast all the information, and your sensitive information will get exposed to the entire network. So this is how you do TCN network, and you can sniff out, and you can do your normal man-in-the-middle attack to complete your whole spanning tree protocol attack. You can get some sensitive information by sniffing attacks and R poisoning attacks, right? That's very easy in here. And the next thing we have in here, next to TCN attack, we have a DOS attack using your BPDU DOS attacks. Okay, so how you can do this BPDU DOS attacks? Simply that we have done this thing, right? And when you're doing this stuff, this BPDU DOS attack, exactly the same one, it will create lots of packets, causing the switch to consume its CPU processing resources. So you can easily verify that thing in your switches, and by verifying the CPU usage, and that will cause the by exhausting the resources into the switches, that leads to the DOS attacks on switches. Okay, so by sending multiple BPDU packets, and you can exhaust the resources on a switch. Okay, so this is how you carry out BPDU DOS attacks. Then you have multiple attacks in here. Next we have VTP attacks. What is this VTP attacks? Virtual LAN trunking and VLAN hopping attacks. So VTP is a different one, and DTP is a different one. Okay, so when you go on with DTP, you can send DTP packets, and you can enable trunking. What will happen if you don't enable trunking? You will be creating a fake trunking port, and then that's what you'll be like introducing that you are a trunk port. So what will happen? Everyone will get introduced into yours, and they'll share information. You are just pushing up all the things, and you will be starting your stuff in here. So I've just enabled trunking in here. Okay, then I'll just, okay, for some reason Athena got closed in here. I don't know why. Athena is very unstable in here with this stuff. Let me launch it once again. Okay, so we have Yersinia in here, and you can do the trunking. You can enable your trunking in here. After that, you can go for VTP. So in VTP, what you can do lots of stuff in VTP. You can send a VTP packet, and you can delete all VTP LANs that you have in your network, or delete only one VLAN. If I just give this, by creating a DOS stack, it will delete only one VLAN. And I can give my VLAN ID in here. You can see this Windows. If you can't, okay, I can give the VLAN ID, and it will delete that VLAN only. Or I can go on by deleting or adding one VLAN. Okay, I can go on with this also, and I'll just click OK, and I can add VLAN 1, and I can add VLAN name as like test. Okay, so I can add it this way. So before that, you need to launch your attack. So your attack will goes on in this way, and you can verify your attack is going on in here or not. You can see VTP adding on VLAN, and you want to stop your attack, you can stop your attack in here, or you can do the trunking one also. Okay, so that's how we do the VLAN hopping attacks and VLAN trunking protocol. So what we have in here in VLAN hopping, we all know VLAN hopping attack is an attack where attacker tries to get into a restricted VLAN from his VLAN to another VLAN, from VLAN 1 to VLAN 2, like that. So what will happen when we go on with TTP, when we launch an attack, we'll try enable the trunking protocol, and that will enable the trunking, okay, in his VLAN, and it will automatically convert your VLAN trunking protocol and VLAN trunk port, and automatically attacker without any authentication, and he can easily get into the another VLAN without any getting into any protocol layer 3 devices. So once we did this trunking protocol, it will enable it will go for enabling the VLAN trunking protocol, and it will ask everyone to give up the information, and everyone will be sending all the things, and he can directly listen to all the informations in a network without getting into the VLAN 2 or without getting into any layer 3 devices. Okay, that's how we do VLAN hopping attacks and using VLAN trunking protocol, and that's how we do spanning tree protocol attacks also. And you can perform DHCP starvation attack, and you can do CDP DOS attacks too. So it's a very good tool that we can carry out more than a couple of attacks that you can perform with routers and switches. Okay, so that's it in here, and I hope we have covered a lot of good stuff that how you can do penetration testing on your switches, routers, and I'll try to cover soon the IDS, IPS, and firewalls too. And you can find lots of books and stuffs for IDS, IPS too, and that's why I've made dedicatedly for how you can you will get an I hope I know that you have an idea that how you can do penetration testing on routers and switches, that okay, this is what I'm going to look in when I'm getting into the network security. Okay, so that's why I've made this video particularly. Okay, so don't forget to subscribe us, and please hit the bell button, and so that you can get notification whenever we upload a new video. Okay, thank you so much. Bye.